Welcome to Chapter 4, Part 3, and the last part. We're going to run through the rest of the water pollution right now. Okay, so oil pollution is a very big deal. Oil spills are a very big deal. Oil is highly toxic to organisms, animals, birds, mammals, humans. So it's a very serious thing. It persists in the environment. It's very difficult to remove, and it's very difficult, and it takes a long time before it'll break down. So if you have an oil spill, it's going to be there for years and years and years. Offshore oil platforms often leak. There are natural seeps where oil will seep out of the ground underwater and stuff like that. But then most of our problem is our oil spills are accidents that happen. Two oil spills you should be familiar with. The Deepwater Horizon platform, which this was an explosion that occurred in April of 2010. It resulted in the largest oil spill in history, about 780 million liters of oil. Occurred in the Gulf. It was a BP, British Petroleum platform that this happened to. It wasn't sealed until August of 2010. They initially didn't report that there had been a problem kind of thing. And that there was a leak. Everybody knew the platform exploded and stuff like that until later they were trying to deal with it themselves. And then it kind of came out and they had to ask for help because they couldn't get it to stop. And it ended up being this huge disaster. Tons of beaches damaged, estuaries damaged, lots of wildlife dying, destroying the fisheries, fish and shellfish, and lots of jobs in tourism. So huge environmental damage, but also a huge economic damage to your fishermen, to your tourism business, to those beaches that were all heavily affected and still are to some degree being affected. The other another large oil spill was the Exxon Valdez, which was an oil tanker that ran aground in Alaska. In 1989, it dumped 41 million liters. At that time, that was the biggest dump that had occurred. But now, of course, the Deepwater Horizon is bigger. Even today, almost 30 years later, they still find oil from Exxon Valdez. One of the biggest problems they had is with the oil. It would travel really badly when they went to try to get it. It was in an area where the tide would move it around. They'd find a slick of oil and call it in for somebody to come, boom it off and try to clean it up, and it would move before they got there. So it was very difficult to clean up. And we'll talk about how we clean up oil spills in just a minute. So, different sources of oils. Again, natural seeps is quite a bit, and that's natural. Okay, nature can probably, deal with that. But there's a lot of other things. When your car drips oil on your driveway and that kind of thing, that all contributes to this too. But of course, this is what it is, and I hope you can see the poor little bird right here. These rocks are covered with oil completely, and so is he, unfortunately. I wouldn't be surprised if this is an Exxon Valdez picture, because this is a lot of what happened. So how do you deal with this? Well, first off, if you have oiled birds or mammals, you have to clean them by hand. So you have to catch them. You have to hope they have not ingested so much oil that they're going to die, because oil is toxic, and they will ingest it trying to clean themselves. So you have to get them in. You have to then clean them, and yes, we use Dawn to do that. And then you also have to keep them warm, because their way of staying warm is now gone. So you have to keep them warm and dry, and this is a process that has to be repeated to finally get all the oil off them, and hopefully before they've eaten too much of it or consumed it. Okay, surface oil, stuff on the surface of the water. Usually what we do, we use something called a boom. It's basically a series of floats, if you will, on a long rope that's kind of end to end. And we encircle your floating oil so it won't spread, and we can keep it in a circle or in an area, so then we can deal with it. There's a variety of ways to deal with it. We can try to suck it off the surface. We can use bacteria that will help to decompose it. We can burn it, which of course just turns it into air pollution, but it's still an option. There's lots of different options we can use. None of them are fabulous. All of them produce a lot of hazardous waste or waste that we need to then take care of. But we're always looking at new ways to deal with it, but hopefully we'll have less accidents in the future as we get better. Although as we continue to go after oil that's in deeper and deeper water, chances are that our situation will get better rather than worse. Underwater plumes, the little seeps and stuff like that, there's no way, we don't know how to deal with that. That's under the water and stuff like that. Hopefully they're just not that big and nature will take care of them. If oil ends up on rocky shorelines, like the picture I showed you with the bird, the best thing we can do is actually pressure wash it with hot water and back into the water and then try to clean it up that way. You can try wiping it off with rags and stuff, but that's extremely time consuming. And then the rags have to be treated as toxic waste. So it's not the greatest, yet probably washing it back into the ocean isn't the greatest either. It's a very difficult process. Either way, no matter how you look at it, oil cleanup is a very difficult process. And so it's better to prevent them. After the Exxon Valdez, one thing the United States did was they required that oil tankers be what we call double hulled. In the old oil tankers, like literally when you saw the outside of the tanker, right on the other side of that metal was the oil that sat in the tank, or right in the center of the tanker. Now there has to be a tank of oil inside the tanker. So there's a gap. You have the outside hull and then you have an inner tank. So there's a gap. So if you run aground and your outside of your tanker was to rupture, it still wouldn't release the oil. It would have to go through two tanks, the outside of the tanker and a tank inside to actually release oil. Although not all countries did that, so what you will see is most tankers are not registered in the U.S. They use a U.S. ship. They're registered in the Bahamas or some other country that does not have those regulations, and therefore they get away with not having the updated system. Okay, so we're going to run through 4 other types of water pollution. That would be solid waste or garbage, sediment pollution, which is sand, silt, and clay in the water, and then thermal pollution and noise pollution. And then we are done. So solid waste is this. Isn't that lovely? Look at all that nice garbage. Kind of gross, huh? Very serious condition. Animals get tangled, animals consume it and starve, or it kind of blogs their digestive system, or they think they're full and they can't pass it. Albatross are a classic example of this. In the North Pacific, there's what we call the North Pacific Gyre. It's a big circular current, and for whatever reason, it keeps kind of concentrating a lot of plastic in the center, and we call it the Great Pacific Garbage Patch. Albatross nest in that area, and the parent albatross go out to find little fish to feed their chicks, but what they're finding is little pieces of colorful plastic, and they're feeding that to their chicks are eating it, and it's clogging up their stomach and all. The chick feels full because there's plastic in his stomach. He doesn't know the difference, and so he stops begging for food, and then he's not being fed and he's going to die. And now unfortunately a lot of the islands in the Central Pacific that the albatross use for nesting are now covered with carcasses of albatross because they're consuming so much plastic. They don't get it. It's pretty and colorful like the little reef fish. They think they're eating a fish. Sad but true. We need to be concerned about this. It causes huge harm. Animals get tangled in it. It's nasty. It's bad, and we need to be careful. Trash bags occur, and a lot. And that can be a great issue as well. So Then we have sediment pollution. This is sediment. You can see those rings of sediment. This is a river that has lots of erosion occurring, so it has lots of sediments coming in and dumping this. Sediment can block sunlight penetration. It can increase the temperature of the water, which can be bad for animals. It can kill animals. And then that sediment can settle out on animals and suffocate them, block their gills, that kind of thing, and cause death as well. So, in all those ways, sediment can be very bad. A little natural sediment is one thing, but this is usually human caused due to construction or erosion, that kind of thing. Our practices and stuff increases ocean. And then we have thermal pollution. Thermal pollution is often caused from industry using water to cool its processes. And this is a nuclear power plant in Iceland, and so it's dumping, they're releasing a lot of hot water. That hot water can be very high in temperature and kill the animals that would normally exist there because they can't deal with that kind of temperature change or that increase in temperature. I actually do not have a slide for noise pollution. It's kind of hard to do, but noise pollution is an issue with anything humans do in the water creates noise. One of the biggest culprits is sonar. When we use active sonar and we ping, it really seems to bother marine mammals, especially those that have the echolocation and all. And it's been known that in areas where active sonar testing and stuff has been going on, there are marine mammal strandings. Marine mammals beach themselves up on the water to get out of the water, and often in very large numbers. It's been a number of years ago, but the Keys had over 220 dolphins strand themselves during some active Navy active sonar testing about 10 years ago or so. So that's of great concern, especially when we refer to marine mammals, and most marine mammals, of course, are endangered in the first place. Okay, so a couple laws you should need to be familiar with. We have the Clean Water Act and the Safe Drinking Water Act. The Clean Water Act was basically in 1972, we decided that our waterways were way too polluted. And the Clean Water Act was set up in order to make sure or maintain the quality of our surface water, so our rivers and lakes, not groundwater, just surface water, so that it was safe for swimming and fishing. So recreational use. It wasn't necessarily safe for drinking, but you could swim in it and you weren't going to die, and you could eat the fish out of it and play in it, that kind of thing. So it was more for recreational use for fishing and swimming. And it did. It's worked quite well to help clean up our waterways. They're not pristine, but they're a lot better than they were. And then in 1974, they put in the Safe Drinking Water Act, and this has been kind of improved over the years. It basically maintains or establishes a maximum contaminant level of 77 different elements and contaminants in water, and those are monitored to make sure that they are safe. If they, for some reason, fall out of being safe, people will be notified and adjustments will be made to try to make the water safe, kind of thing. Some of those are things like Giardia, the fecal coliform. Giardia has to be 0. Fecal coliform, of course, 0, because we don't want any fecal material contaminating our water. Arsenic is 10. People don't like that it's 10, but it's a naturally occurring thing. There's not much we can do about it. It's not like we're putting it there. It's natural. Then mercury is 2, benzene is 5, and atrazine. Atrazine is the herbicide I was telling you about that causes frogs to become girls. Okay, so that can be 3. Okay, and then this is just a table showing causes and sources of some of the problems in our waterways. Streams and rivers can have bacterial pathogens in them, habitat alteration occur, and oxygen depletion can occur when pollution occurs. And often these are the sources of these pollutions are agriculture, water diversion, and dam construction. Lakes, ponds, and reservoirs have mercury contamination, PCB contamination, and then excess nutrients, of course, that can lead to eutrophication. And these are often from atmospheric deposition and then agriculture. And then bays and estuaries, larger marine environments, biological pathogens, oxygen depletion, mercury, again, coming from eutrophication and those kind of things from municipal things, sewage waste dumps and that kind of thing. Okay, so that rounds out chapter 14. I hope you've learned a lot. If you have any questions in class, please, please, please let me know. This is very important chapter that you understand before you head into the AP exam. And we are right around the corner for the AP exam, which is rather exciting. So have a nice evening and let me know if you have any questions. Thank you.